Hello everyone and welcome back to our course. In the previous section we learned how we can analyze features of our stock data, and in this section we're going to learn how we can calculate risk. Starting off, we're going to learn how we can visualize standard deviation with a graph. So let's jump into our same project, continuing on, and we're going to make a new code cell. Here I am going to first get all of my returns, and those are inside of stocks returns, and I'm just going to make sure to drop any null values with the function drop NA. Then I can save that as a new variable called my returns. Then I'm going to use pyplot to create a new scatter function. Let's pass in an x-axis. The x is going to be our returns.mean, so the average of our returns. The y is going to be our returns.standard. And in this way we're plotting the standard versus the mean. We're also going to pass in a value that can define the area for the circles in the plot. And that is an argument known as s. So let's create here circles area. And let's create that variable, circles area. We can just use numpy.py times a value like 15. NumPy is another library that we have to import, so we can just import the NumPy library. The NumPy library has a lot of useful tools for scientific computing and data science. For example, it has the NumPy type, which means that it acts as a regular Python list, but has a lot more capabilities, a lot more functions, and also the NumPy list type or NumPy array type, it is much faster in terms of processing. That means it's perfect for data science and machine learning, which can often use a lot of data. All right, so here I've defined a scatter plot. And next, let's set labels. So we can set the x label for the x-axis. This will be expected returns. Then let's use pyplot.y label to label the y-axis. The y-axis is risk. All right, and I can already run this code cell and see some action. Look at this. We have risk versus expected returns. And I want to make a loop to go through all of my data. So for every label, x and y, in a zip of my returns.columns, my returns.mean, and my returns.standard. Right? So I'm looping through the label, which is the columns, the x, which is the mean, and the y, which is the standard. And I'm going to call pyplot.annotate to create a new annotation at every single coordinate. I'm going to pass in the label, which is the text. The xy argument is an xy pair. The xy text argument is going to be 50-50 for the size. Then we're going to pass in text coords. I'm going to use offset points, as well as HA is going to be right and VA is going to be bottom. Then we can also pass in arrow props. This is going to be a dictionary where we can set the arrow style. I'm going to use just a dash, and we can set connection style to equal an arc3 with a radius of -0.3, very commonly used. And that just sets the type of arrow. So now if I rerun this code cell, okay, look at this. Now we just have here an arc pointing to the data point and then an annotation explaining the data point. So we have risk versus expected returns. We have 4 blue dots because we have 4 different stocks in our data set. And here we can see we can compare. We have first each stock's expected returns on the x-axis. Facebook had the smallest expected returns and Amazon had the highest expected returns, but even still all the returns are quite close to each other because our graph only goes from about 0.001 to 0.0025. All right, and let's see. On the y, we have our risk going from 0.024 and all the way to 0.031, so still not a huge range. And we can see that lowest risk was the Amazon stock, and it also had the highest returns. The highest risk was the Netflix stock, but it did have the second highest returns. So look at that. We can get quite insightful data by building out this visualization, or we can visualize the standard deviation. Standard deviation, also known as risk, and expected returns is the average of all of the returns for that stock. All right, next up, we are going to learn how we can calculate value at risk and also visualize it. So join me in the next lecture where we will work on that.